Hello everyone. Today I want to talk something about my project for wireless communication. My topic is performance analysis of LMUT space-time code and MRC receive diversity. In this paper, the effect of time-varying multipath fading of wireless channels on wireless communication is analyzed by introducing LMUT space-time codes and the maximum ratio combined receive diversity. As for the space-time coding technology, which is also called STC, is a revolutionary development of the performance of multiple input, multiple output system, which is called MIMO, by using area antenna processing technology, which can effectively offset fading and improve spectral efficiency. Now let's see the current situation of MIMO. As people's demand for information grows, the next generation of wireless communication systems must be able to provide higher transmission rates and better transmission performance. There are two methods to improve the spectral efficiency of wireless communication systems. One method is to approximate the channel capacity of a single input, single output antenna receiving system by using higher order modulation techniques and better channel coding methods. And another method is to increase the channel capacity of the system by using MIMO antenna technology without increasing the bandwidth. And the benefit is that because MIMO technology has many advantages, it has received widespread attention once it was proposed, and it has become one of the breakthrough technologies for achieving high-speed and reliable transmission in future mobile communication systems. And now let's go to the diversity technology overview. In mobile communication systems, in order to overcome the effects of fast fading, the commonly used anti-fading and anti-interference technologies are diversity technology, equalization technology, coding technology, and so on. In diversity technology, the base principle is to receive multiple copies of the transmitted signal carrying the same information through multiple channels with different characteristics. And the diversity technology includes two aspects. One is decentralized transmission, which enables the receiver to obtain multiple statistically independent fading signals carrying the same information. And the other is centralized processing, that is, multiple statistically independent fading signals received by the receiver, combined to reduce the effects of fading. Therefore, to obtain the diversity effect, the most important condition is that each signal needs to be irrelevant. And next, let's talk about space diversity. Space diversity is a commonly used form of diversity. It refers to a method in which the same information is encoded and transmitted from multiple antennas. The receiving and distinguishes the signals and combines them to obtain diversity gain. The model is shown in the following figure. And as for receive diversity, diversity receiving technology is a main anti-fading technology, which can greatly improve the transmission reliability under multipath fading channels. The essence is to use two or more methods to receive the same signal to overcome fading. Its role is to make full use of multipath signal energy brought by the transmission without increasing the transmitter power or channel bandwidth to improve the receiving performance of the system. Transmit diversity. As the main method of anti-fading has become a hot topic of discussion in recent years, and has been well applied in some mobile communications. Transmit diversity technology is also easy to combine with space-time coding, (OFDM), interference suppression, and smart antenna technologies to maximize the reliability of physical layer information transmission. So it has very high theoretical value and far-reaching practical signature. And now I will talk something about STC technology. Space-time coding is a coding and signal processing technology that has appeared in the field of mobile communications in recent years. It uses multiple antennas at the transmitting and the receiving ends to transmit and receive information at the same time. Related to the spatial domain, the two-dimensional information in the time domain and the spatial domain is comprehensively used for diversity reception at the receiving end. Space-time coding combines spatial diversity, frequency diversity, and time diversity. From the overall perspective of the communication system, the communication quality and the quantity of multipath fading channels are improved. Space-time block code set based on transmit diversity. Transmit diversity and the space-time coding are integrated into one. It has good frequency and power efficiency, greatly improves the information capacity and the information rate of mobile communication systems, and makes full use of wireless spectrum resources. The data shown that the space-time code frequency band utilization based on transmit diversity can reach from 20 to 40, which can reach the maximum diversity gain provided by the system. And now let's go to the simulation scheme of BER performance curve based on MATLAB. I will show you my program. The first simulation is 2x1 Alamute space-time code simulation. Through simulation, I evaluated the performance of the Alamute space-time code transmit diversity scheme for the slow relay fading channel and assumed that the fading of each transmitting antenna is independent of each other, and the receiver is fully aware of the number of channels. I used the coherent BPSK modulation to simulate the BER performance of the Alamute scheme with respect to the signal-to-noise ratio of each receiving antenna. The number of transmitting antennas is 2, and the number of receiving antennas is 1. During each symbol period, the average signal power is 1. The noise component uses a complex Gaussian random variable with a mean value of 0 and a variance of 2. The channels between the transmitting and the receiving antennas are independent flat relay fading channels. The real and the imaginary parts of the channel coefficients follow a Gaussian distribution with a mean value of 0 and a variance of 0.5. The channel coefficients remain unchanged during the transmission time of a data packet. There are ideal channel estimation methods at the end. The simulation results are shown in the following picture. And now the second simulation is a 1x2 MRC aspects diversity simulation. In this simulation, I set the variable gain weighting coefficient of the ice branch as the ratio of the signal amplitude to the noise power of the diversity branch. The combination scheme of MRC receiving diversity only leads to perform linear processing on the signal at the receiving end, and then use the maximum likelihood detection to restore the original information at the transmitting end. The merging gain is proportional to the number of diversity branches M, and the simulation results of 1 by 2 MRC receiving diversity is shown in the following figure. And next, the third simulation is 2 by 2 LMUT spacetime code simulation and comparison. It adds a 2 by 2 LMUT spacetime code performance curve to the above BER curve, and the simulation results are shown in the following figure. After these simulations, we can obtain three conclusions. The first one is that when the gain of receiving antenna gradually increases, the bit error rate of the received signal gradually decreases. That is, the larger the antenna gain, the higher the signal reception quality. The bit error rate of the received signal is decreasing, indicating that the larger the gain of the receiving antenna, the better the quality of the received signal. And it can be seen that the change of the signal bit error rate with the gain is basically monotonous. It can also be seen from the above figure that under the same antenna gain, the bit error of one receiving antenna is higher than that of two receiving antennas. That is, the more the number of antennas under the same conditions, the better the signal quality it receives. And at the same time, it can be seen from the simulation diagram that the simulation image of 2 by 1 transmit diversity shows a regularity similar to that of 1 by 2 received diversity, and the amplitude is slightly different. It can also be obtained by comparison that under the same transmit diversity conditions, the more the number of receiving antennas, the lower the bit error rate of the received signal. That is, the higher the signal quality. At last, as for a future outlook, spacetime code based on transmit diversity is one of the most effective methods to improve the utilization rate of wireless spectrum. It will surely be widely used in the future mobile communication systems. There are many places to be improved, and how can the spacetime code based on transmit diversity be effectively combined with smart antenna technology, multi-user detection technology, equalization technology, MTCM technology, OFDM technology, and so on. There is still a lot of work to be done. Above all, research efforts in these areas should be vigorously strengthened. Continuously breakthroughs in core technology and continuously maturity and improvement in theory, so that in the future mobile communication systems, spacetime codes based on transmit diversity are used to improve spectrum utilization, play a more prominent role. Thanks for watching.